Hello everyone, this video is about binomial distribution. In the next set of videos, I discuss problems on binomial distribution. This video will introduce you to the fundamentals of the binomial distribution and the terms in calculating the binomial distribution. Binomial distribution is a discrete probability distribution. So in case if you don't understand what is discrete probability distribution, if you have a random variable, if it takes finite number of values, then it is a discrete random variable. In order to estimate probability of a discrete random variable, we apply binomial distribution. So, random variable in binomial distribution can take set of possible values in finite, means number of possible values for a random variable in binomial distribution is finite, means so here is one such example. So these are the conditions for which you can apply binomial distribution. You may want to measure the probability of getting 3 heads if you toss a coin 6 times, or if you want to measure the probability of getting 2 tails if you toss a coin 6 times. The underlying phenomena in these two experiments is if you toss a coin 6 times, you can get 0 heads, 1 heads, 2 heads, 3 heads, so on and so forth, 6 heads. So if I am interested in getting 3 heads in 6 coin tosses, the binomial distribution can help you. Here is another example. If I want to measure the probability of getting 1 as the outcome if I roll a dice 10 times. So if I roll a dice, I can get anything as an output between 1 to 6. But I want to measure the probability of getting 1 times, or 1 2 times, 1 3 times if I roll a dice 10 times. If you have any of these kind of requirements at your hand, then the binomial distribution can be used. Underlying definition of the binomial distribution. Basically, we want to measure the probability of getting x successes in n trials, where x is less than or equal to n, where the probability of success in every trial is denoted by p. In shorthand notation, the binomial distribution is denoted with binomial of x successes in n trials, and probability of success is p is fixed for n number of trials. So in our coin toss experiment, x is probability of getting 3 heads, n is 6 times we are tossing a coin, and p is 0.5, what we have fixed, that is probability of getting head or tails in every successive coin tosses. So here the binomial variable for getting 3 heads in 6 coin tosses and probability of success is 0.5 is given on the left hand side, and probability of getting 2 heads in 6 coin tosses and the probability of getting tail is 0.5 is given at the other end of the slide. So basically, what I will get as an outcome or an output if I measure the probability using binomial distribution, you will get a graph like this. On the x-axis, you will have a random variable. Random variable is, for a coin toss experiment, number of heads in 6 coin tosses. So if I toss a coin 6 times, I may get 0 heads, I may get 1 head, I may get 2 head, so on and so forth. I can get 6 heads in 6 coin tosses. So the possible values for the random variable, if I toss a coin 6 times, can be 0 to 6. Okay, so the next thing we need to measure is the probability of getting each one of these outcome, means 0 heads, 1 head, 2 head, 3 head, 4 head, and 5 and 6 heads if I toss a coin 6 times. That thing we can see in the y-axis. So this is the outcome. If I populate the probability of each of this value for the random variable, that completes the binomial distribution calculation. So for this kind of problem, probability of getting outcome as a 1 if I roll a dice 10 times. So on the x-axis, you have the entries of the random variable. Random variable is number of times dice shows face 1 in 10 dice rolls. That is a random variable. So random variable can take value between 0 to 10. So if I roll a dice once, I may or may not get 1 as the outcome. If I roll dice 2 times, I may get 2 times as 1 outcome, or I may not get 2 times as 1 outcome. So it all depends on the probability. So we will measure the probability of getting 0 to 10 times 1 if I roll a dice 10 times. At most I can get 10 ones. I cannot get more than 10 ones if I roll a dice 10 times. So these are the conditions for applying binomial distribution. So if you have any problem at your hand, if that problem conforms to these conditions, then you can apply binomial distribution straight away. So if there are n number of trials and these trials are fixed and these trials are Bernoulli trials, don't worry about the word Bernoulli trials. The Bernoulli trial is an experiment where we have 2 possible outcomes. Okay, so if you have n number of trials and number of trials is fixed, and the second point is every trial is having 2 outcomes. In the coin toss, head or tail, in a dice roll, I may get 1 as the outcome, or I may get the outcome between 2 to 6. These are the 2 categories of outcome I can get. Or in an experiment, you can get yes or no as the outcome. So if an experiment is having 2 possible outcomes, then the binomial distribution can be applied. And the third condition for applying the binomial distribution, probability of success in every trial is fixed. If I am interested in measuring number of heads in n coin tosses, then the success is defined as getting head. So the probability of getting head in every trial or every experiment is fixed. And every trial is independent of each other, means the next experiment or the next trial is independent of the previous experiment or the previous trial. This is the fourth condition. And the fifth condition is, if you want to find out the number of success 0 to n successes in n trials, then the binomial distribution can be used. Whenever you are having the binomial distribution problem at your hand, you check if all of these conditions holds true for the binomial distribution problem or any probability calculation problem, then the binomial distribution can help you. So in binomial distribution, we define the outcome of our interest as success and the other outcome as failures. So head, if I want to measure the number of heads in 6 coin tosses, success is defined as head. If I want to measure the number of times I get 1 as the outcome, if I roll a dice 10 times, then getting 1 as the success. If I get any other outcome, that is a failure. So here in this experiment, getting head is a success, other outcome is a failure. In this experiment, getting tail is a success, other outcome is a failure. So you need to define success and the failure criteria of every trial you are going to define. So the binomial distribution formula, how do I estimate the probability of getting x successes in n trials and probability of success is fixed, is given by NCX. It is a combinatorial term. Here x success in n trials we are defining, and it is expanded with the help of NCX is given by n factorial divided by n minus x factorial into x factorial. So here is x successes in n trials. N means number of trials we are repeating, and we are interested in getting x successes. And this term is multiplied by probability of success, means probability of x successes means p is a probability of success, and if I raise power x to p, then the probability of x successes we will measure. And 1 minus p to the power of n minus x is probability of n minus x failures. So if I get x success, number of failures I will get is n minus x. So 1 minus p is a probability of failure to the power n minus x will give the probability of n minus x failures. So if I want to measure from 0 to n, the x can vary from 0, 1, 2, 3, so on and so forth up to n. This is the binomial distribution formula. So we will apply this binomial distribution formula for a random variable, and we will estimate the probability of getting 0 head in 6 coin tosses, 1 head in 6 coin tosses, 2 head in 6 coin tosses. So n and p will be fixed here. X will be varying between 0 to 6. N is 6, p is 0.5. So we will solve those kind of problems in upcoming set of videos. Again, so binomial distribution will give us the probability of witnessing x successes in n independent trials, where p is the probability of success in every trial is given by the product between number of ways x success can be witnessed in n trials, probability of x success, that is p to the power of x, probability of n minus x failures, that is 1 minus p to the power of n minus x. So this is the final binomial distribution formula. So all the terms which I have explained in the previous slides are put together here. So this formula will give us the probability of getting x successes in n trials, and if p is the probability of success. We will study couple of problems on binomial distribution, and we will solve by plotting the graphs of the binomial distribution for multiple problems in upcoming videos. Thank you for watching. If you have any doubts, comments, or any suggestions, you can leave your comments in the comment section. Thank you for watching. See you in the next set of videos.